right, guys. So we're going to take what we learned yesterday with relations, and we're going to talk more about functions. So I'm going to be doing a screen recording in just a second, and we're going to be looking at sets of ordered pairs, and we're going to determine, is this a function based on using the domain and range. But something that is not included that you will see is a lot of times, like with the textbook, there's a video, and it's talking about these two people that go and buy CDs or DVDs, whatever you want to say. And they're looking in a bin, and it's $15 a CD. So they were saying that if you have X and Y, okay, so if you bought one DVD, it's $15. 2 DVDs would be $30. 3 DVDs would be $45. And 4 DVDs would be $60, right? Okay, so basically, Y is a function of X. Y is determined by how much or what you put in, how many DVDs you buy. Determines your total cost, right? So you'll also see it written like this. So I don't want you getting freaked out. It looks really fancy. It looks really smartical, and it's going to make you look smart when you talk about it, but it's not scary, and it's not really a big deal. But I'm going to expose you to it. So you'll see it written like this. I'm trying to write it big so you can see. So you'll see f of x is equal to 15 times x. And what that means is the function of x. But they shorten it instead of writing function of x. They put f of x. So you'll hear me say it two ways. F of x or function of x. Either way, this means the same thing. So what it's saying is the function of x, the function, which is y, okay, because whatever you plug in for x, whatever you plug in for x will give you your y, basically. So it's saying the function of x is equal to 15 times whatever you plug in over here, okay? Now, why don't they put y there? I don't know. Why do they make it scary and crazy and confusing and give you f of x? I don't know. I did not invent this math. If I did, I wouldn't be teaching you. I'd be probably on my own island somewhere in the Caribbean. I don't know. But this is basically why, if you want to get the function of x, if that's kind of confusing to you and you want to feel better about this, f of x, the function of x, is equal to 15 times whatever you put in here. Now, this is considered a function because I don't have the x is not repeating with a different y. Okay, so if I had 2 in here, if I bought 2 DVDs and it was 30, and then I had 2 in here and then it was 20, that's not a function because the y is a different output. Okay, so it needs to be, the y is dependent on what goes in the x. Okay, or I'm sorry, the x is dependent of, yes, the y is dependent over what the x is. Okay, it's a function. The y is a function of the x. Okay, so I'm going to do screen recording real quick. Okay. So they want us to determine whether each relation is a function, okay? So let's look at domain, this number 1. My x-coordinate right here is 1. Its y-partner is -1. My x-partner over here is +4, and its y-partner is -3. And then, of course, 9 is my x, and it's paired with y, my 5. So yes, each of these coordinates, each of my domains, my x's, are paired with a y. And none of my domain repeats. None of my x's are repeating. So yes, this is clearly a function. So let's look at number 2. All right, so I have my x right here, 2, is paired with 20. Okay, my 4 right here is paired with 15. And my 6 is paired with 20, and then 8 is paired with 20. So none of my x's are repeating. They're all 2, 4, 6, 8. But I can see that my range is 10 and 25, and it's not paired with anything. So this is not going to be a function because I have 2 y's that have no x's, no relationship with x's. So this would not be a function. Okay, so let's go to 3. And looking at this, I'm highlighting it. Hopefully you can see it. I am looking at, I have 5. I'm going to look at my x's first. And I'm going to go ahead and make a little table so hopefully you guys can see it. So I have x, y. I have 5, 6, and 5, 7. Ooh, repeating x's, not a function. 7, 7, and then 7, 8. All right, so we can see that this is not going to be a function because I have 2 x's and they spit out different y's. Well, even if it spit out some, then that would just be a typo, I would think. So we have 2 different destinations for y when we plug in an x. This is not going to be a function, okay, guys? So let's go to number 4, and let's check this out. I'm going to just erase what I have in here. Hopefully that's okay with you guys. All right, so we have 12 and 14. We have 17 and 16. 13 and 14. And 18 and 16. Okay, so I can see that my x's do not repeat, and each x coordinate has a y coordinate. Even though these 2 y's repeat, this is still a function because the x is different, okay? So as you can see, this is a function, okay? So yes, 4 is a function, 3 was not because the x's, my domain, was repeating. Right here, my y's, that is totally fine, okay? Now let's look at this 5 and 6. So we have 1, 2, 3, 2. Ooh, I have 2 repeating 2s. I have a repeating 2 here and here in my x's. This number 5 is not a function, okay? All right, so let's look at number 6. We have 0. Let's look at our x's. That's what I like to look at to just determine first, could this possibly be a function? So like I looked at the x's up here, this could not possibly be a function because I had 2 different x's. All right, so now let's look at this. I have 0, 1, 2, 3. Okay, so it's looking good. I have 0 and 0, and yes, each x has a perfect y partner. That is a function. I hope you guys thought today's lesson was easy, and I tried to make it as short as possible. If you have questions, raise your hand. If you're virtual, email me.